Okay, so I want to take a shortcut here. Instead of trying to write the code from scratch, I'm just going to make ChatGPT write a code. I'm just going to try to plot sine as a function of x, where x goes from 0 to, say, 0 to 2 pi, and see what ChatGPT generates for us. So let's go here. Remember, we had asked the question in the last class. Okay, this was my question. It printed that. It actually stored that in memory. This is good because you can then go and look at what you asked a long time back and use it for your work, right? So we can, rename this. Sometimes you might want to rename it just to keep track, and you can actually develop your own set of notes, and then you can use it or refresh it. Sometimes, you have a very you see these conversations actually tend to be sometimes very long till it actually gives you what you need. And so you might want to save those conversations. And that's a good thing about ChatGPT. And this is all with the free version. I'm not paying anything for this. Okay, so what I'm going to do is I'm going to say, write Python code to plot sine of x in the interval 0 to, say, 2 pi. Yeah, so the good thing is that it basically also gives you a lot of comments, so you understand what's going on. Okay, so all we do now is copy this code and then paste it in here. Okay, let's save it before we run it. Let's call this plot.py. Okay, let's just run this first. Okay, so that's sine 0 to 2 pi. What else? It actually gives me the title, the labels, grid lines, more things than I asked it for. Okay, let me just make this. So this is basically, well, let's look at the code. So import numpy as np. It actually imported another module called, or a package called matplotlib. This is actually used for plotting. Interval, this is kind of self-explanatory. This basically generates 1,000 points. Let me just reduce them to 100 from 0 to 2 pi. Compute sine of y equals sine of x. Plot x versus y. Add labels, legend. Maybe I don't want this. Show grid lines. Maybe I just don't want this. And then show, right? So now if I run this, it will not have the legend, and then it will not have the grid lines. Okay. Now, each time I need to close this, right? And it would be nice if this just closed it by itself in maybe 5 seconds or 4 seconds. So what I can do is I can actually ask ChatGPT to write the code for that. So can you update the code so that the plot window closes after 4 seconds? Okay, so it tells you what changes you need to do. You can use PLT pause and PLT close. So this part is the same as you've seen. So everything is same. So here's where the changes is. There's 2 changes. One is it uses plt.show block equals false, and then use plt.pause for 4 seconds, and then plt close. That's all we need to update. So you could copy paste this and then make it run. But then since I already made changes to the code, it's better to just copy this part. So I'm just going to copy this specific part, and then can delete these things. Okay, now run this. So it shows the plot and waits for 4 seconds, and then it closes it. Okay, super easy. Okay, so given that fact that you could use ChatGPT and then you could modify code, gets us to the next thing. So next thing we'll be talking about is animations. Okay, this is like probably something. Have they taught you animations anywhere before? Like making something move in MATLAB or Python? No. Who has learned animations? Some of you have learned. Is this in a class?
No.
Just for
It was for a class. It was for dynamics of machinery.
Oh, really?
We plotted like 2-degree freedom manipulator.
Plotting is fine, but did you make it move? Like if you have an manipulator, did you make it move? Oh, you did make it move. Okay, so the way animations work is just like a flip book. You make plots for different positions, and then as you turn the flip book, you turn it in a computer. Well, turning in a computer is much simpler because all you do is you plot your first page of the flip book, you pause for some time, you plot the second one. Of course, erase the first one, plot the third one, fourth one, fifth one, at whatever speed you want, so that to make it look realistic. Okay, that's what all to it. What I'll do is, to start off, what I'll do is I'll take the sine function, which is this nice curve, and then I'll just make a colored dot move along the sine function. Okay, so animate that part. So what we'll do is we'll reuse this code. Now, you could just go to ChatGPT, ask it, it'll give you code, but let me do it from scratch. Of course, reusing the code here. So I'll copy this. Okay, let's call this animation. Okay, and then all I'm trying to do is put a dot and move the dot on the sine curve. Okay, so to move a dot, I'm going to keep the curve stationary, just the dot will move. So all I need to do is put the dot at 0, 0, because that's the first point, then erase it, move it to the next point, next point, next point, and so on. So here's what we'll do. Right after we plot sine of x, we'll write code to move a dot on the curve. Okay. So remember that the sine of x goes from 0 to 100. So this gives us points on the curve. So we'll just use those points to go along the curve. So what we'll do is we light a for loop because we want to put a dot each time there's an x value. So for I in range len x. Okay, what this is saying is x has a length. In this case, it's 100, right? So it takes the 100, so that's 100. So I goes in range of 100 means by default, I takes integer value. So it goes from 0, 1, 2, 3, 4 till 100. That's what this thing does. Okay, so that's that. Again, as I said, you put a colon, and that means that the for loop, the condition is defined, and then it'll be indented. Otherwise, it'll give an error. So do plt dot plot. What I need to do? Well, I need to plot a dot at each point. So I need the x and y coordinate of that. So x, I, y, I. Okay, now let's see, since we want a dot, I don't know how to actually do a dot. So what I'll do is, I could use ChatGPT, but let's just use help over here. So in plot in matplotlib. Yeah, I'm just trying to pull off the documentation from matplotlib. Okay, so here are all the various things. I want plot function. Do I see it here? Pyplot, subplot. Not quite. Okay, this is what I want. Okay, so I'm using plot. Don't worry about pyplot. Remember that I imported matplotlib.pyplot in the top. So I just deal with plot. So I need to give the argument scale y. Here it gives me some answers. This doesn't seem very helpful to me, but this is actually more illustrative. So you have x, y, bo. This one, put a blue circle marker. Okay. It's actually much better, I think. It gives you, well, color is green, marker is O, and maybe that's what I want. Line style is dashed, line width is 2, marker size 12. Maybe I should just copy this. So I'm just going to take this and just use whatever I need. So let's go here, copy this chunk. Okay, so what I don't need is line style because I'm just going to make dot, 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 right? So I don't want line style. I don't want line width, but I need the marker size. Let's use these things. Okay, that's that. What else do I need? Okay, so I just placed this. Let's see if this code works. Okay, so well, just drew it as expected. What I need to do is I want to plot a dot pause. So what I'm going to do is I'm going to put a pause. Turns out there's a pause available in PLT, which is the matplotlib library. I'm going to pause for 0.1 seconds, then go. Okay. Okay, so it looks like so there was a problem. You saw it just started drawing those dots and didn't really draw the curve. It turns out that I called the curve later on. So that's my bad. Let's go here, copy this, and paste it here. So it'll first draw the curve, and then it's much easier to make sense of the code. Let's make sense of the animation. So it plots first, and now it goes. Okay, so that's an animation, but we don't quite want like that. There's only one dot, and that dot has to move. So what we'll do is we'll have to actually take the previous dot, erase it, and plot the new one. I'll run this again. Stop. Okay. So the way to do that is, oh my God, I didn't put a loop. Okay. Control C can save you sometimes. You go to the terminal to Control C. Okay. So the way to erase it is, I'm just going to give you the syntax. TMP equals, so this is basically taking this plt.plot. Basically, it's like a variable and assigning it to TMP. And what you do is you basically erase that off. So what you can do is to erase it, you just say tmp.remove. So every time it's assigned a variable TMP, you remove it and then make the plot again. So let's see how this works. Okay, as expected. If you think it is too slow or whether too fast, then you can increase the pause, make it, let's say, 5. Now it's going to go really slow because the pause has been increased. So it's going slower at the where it changes, where it hits the maximum because there are more points over there. So if you wanted to go equally spaced, then you want to tweak this. This has to be tweaked, right? It just depends on goes up this. So another way of slowing things down is to increase these points. So if you make them 400, it'll go even slower, right? Okay. So the next part is we're going to get into some really fancy animations. I will actually show you how to make create animations with patches. So you can make circles, rectangles, and so on. And once we learn that, we can then create these animations for the codes, like a car moving, could be a rectangle, could be a triangle, whatever you want. So let's get started with that. I'm going to use NumPy, and then I'm going to use matplotlib.pyplot as PLT. Let me save this as animation 1c.py. Okay, so my goal is to do the following. It's basically show a wall and then have the sun behind the wall, a circle, and show that you can get the sun to rise and go down. Very simple. Okay, how would you do that with Python? So first, let's create the wall. So we'll create a rectangle patch. Okay, now the way you write this is PLT rectangle. It doesn't give you information about it, but we can ask here Python in matplotlib. Okay, so here is the rectangle. So rectangle XY. So what's X? The first argument is basically the corner of the rectangle and then the width and height. Okay, so if you want the rectangle, let's in this case, we'll put at 0, 0. And then width, let's say we wanted 2 meters or 2 whatever units, and height is 1. And then there are other arguments which you could use. So the angle would rotate it. You could rotate it about any point. In this case, if you say 0, 0, rotate about this, about the bottom left corner. And then there are other arguments, and those arguments are listed here. One of the arguments of interest is the color. So we just make it, let's say, I don't know, brown in color. So this is how we'll write it. So 0, 0, 0, 0, x, y. That's the first argument, the corner. Then we want to specify the width. So that's, let's say, 2 units. 1 is the height. And then we want to have some color. So color equals brown. Okay, it's always a good idea if you write something to view it. So what we'll do is we'll try to plot it. Now to do this, you need something which is, well, let's put fig equal to plt dot figure. And then you actually need to define the subplot, otherwise you can't plot it, the patch. So okay, now this is not very obvious. How did I find this? Well, I found it by looking at an example of how to do this using a patch. And that's how I know I need to do AX equals fig.supply. It's really not very obvious how this comes, but you can use ChatGPT to generate initial code for something else and learn from there. So this is how I can plot it. Now with AX, I can plot it as AX dot add patch. Patch angle. And then in order to display it, I need to do the same things which I did earlier. Let me do plt dot pause. So I want to pause it for, let's say, 3 seconds. And then I want to do plt dot close. Okay, let's see if this runs. Okay, so you see it's 1 unit and 1 unit off. I wanted it 2 units. It turns out that by default, it plots 1 by 1. And so in order to make it bigger, what I'll do is I'll add limits. So plt.xlim 0, 2. So it's going to be 2 units along the x, and then plt.ylim 0, 2. So it's going to be 2 by 2, right? So run this. And now it's 2 units and 2 units up. Okay, and I'm going to show that's basically the wall, and I'm going to make the sun go up and down. Okay, so we got that. Okay, I want to teach you how to draw a line. They're very useful. So what we'll do is on that black wall, we'll draw a black colored line, horizontal line, to demarcate the top of the wall. So let's create a patch, which is a line. For that, you use plt.line 2D. Clearly, there is a 3-dimensional line. If you want to find the syntax of how to use it, you can go back and then try to see the input arguments. But the first, okay, this actually is, I think, is important. Let me explain this. let's do matplotlib line 2D. So x data, y data. So what you need here is to give the x coordinate of the two endpoints and then the y coordinate of the two endpoints. So if I'm going to draw a line right on top, that line sits at, so left side is x equals 0, y equals 1, and the right side is x equals 2 and y equals 1. So the x coordinate is 0 and 2, y coordinate is 1 and 1. Okay, so let's go to here and then write 0, 2. That's the x coordinate of the two points. And then the y coordinate, it's at the same vertical height. So the y coordinate is going to be the same. One, comma, 1. Okay, what else? It turns out that I can also specify a line width. So let's say that's 5. And then I can specify a color, black. Okay, in order to plot it, I need to go here and say ax.add patch line. This is basically the variable I've defined for the line 2D. Okay, so it's an error. It's good. So you can see that there's a black line. Okay, let me hold it on for a little bit more time. Okay, as I said, the x coordinate is 0. Sorry, x coordinate, yeah, 0 and 2. That's why 0 and 2, and then 1, 1. That's why it's what it is. Okay, so I've got that going. Let's draw the circle now. Okay, first let's draw a stationary circle and then move it around. So patch circle. You can call this anything you want. plt dot circle. Okay. Let's go matplotlib circle. Okay, so it gives you the syntax. You need to specify the center xy and the radius. And then there are other arguments which basically could be the color and so on. So we want yellow color clearly. So let's go here and then specify the center. Let's see. So we want it above the wall so we can see it. So I think a good point would be midway. So midway is x equals 1. And since our wall ends at 1.5, so I'm going to put 1, 1.5. That's the center. And then I need to specify the radius. I just have 0.25. And then color equals yellow. Okay, then again, the same thing. ax.add patch circle. Okay, that doesn't look like a circle. It looks like an ellipse, right? It's because what's happened is the aspect ratio, my computer screen is rectangular, right? It's rectangle. And so when you plot that, it actually becomes stretched in the x direction. So in order to address that, what I need to do is I need to set the plot to be have equal aspect ratio. So for that, what I do is I can go right here and then say, and you'll have this in almost every code you write, this particular function called gca.set aspect. Okay, how did I find? Again, I looked at a code with ChatGPT. You can actually ask it, tell it the question that is, how do you make the aspect ratio equal? And it'll tell you this command in matplotlib. Let's run this. So it looks fixed. Okay, so we're very close to finishing this off. The only thing we need to do now is the animation part, which is get the white blob, the yellow blob to move down and up. So we're going to move it along the y-axis. Okay, so in order to make it move on the y-axis, just like the sine plot, we need to give it some coordinates, some points to move. So let's say that it's starting at 1.5. We want it to go all the way to 0.5 and then come back to 1.5. Right. So for that, what we'll do is we'll create uh, basically some points for it to move. So let's say y equals np dot lin space 0.5. So let's say 1.5 to 0.5. So it's up in the sky and you want it to go down. And let's say there are 20 points. And then y2 equals np dot lin space. Now it's down below 0.5. I need to go up 1.5. And I would put, let's say, 20 points. Okay. I want to join them. So it's continuous. So y equals, there's a function called concatenate. I'll use that. What I want to do is join y1, y2. Okay. So there I have the points. I just need to move the circle. Okay, so remember that the ball stay that it is, the line stay that it is, it's only the circle which is moving. So that's the one I'm going to move. So what I do is I go for I in range len y. I need this. Okay. Now here, what I want to do is I want to keep the x same, but I want to move the y. So I'm going to just make this to be y. Okay. Okay, that was a disaster because I did not add the pause, right? Let me add the pause. PLT dot pause 0.2. Run this. Okay, this is a mess because what happened was you can see it's scaled back to 1.11. That's because I need to call this inside. This has to be inside. All these things have to go inside just before this.
And you have to delete the previous iterations of one ball.
Yes, let's do that. Absolutely, I'll have to do that. Okay, yeah, this is the problem, right? I need to fix it. How do I delete it? Well, I showed you how. I need to create a variable for that and then just delete it. So patch circle is already defined. All I need to do is I need to delete it. So it's to patch circle dot remove. Okay, there's still a problem. See what's happening? It's like it should be behind. So one way of fixing that, okay, there are quite a few ways of fixing this. One is you could actually take this two things and put them here. So it's always plotting the circle first. And then this, I think this will work. Let's see if it works. Yeah, it worked, right? So it plots the circle first, then the wall that way.